Okay, I will share my screen to start. Okay. So let's start with the part one, the magician overview. In the society of Industry 4.0, robotic arms are used in every aspect of our lives. And the role of the Dobot magician is the strong supporter and pioneer of combining AI, STEAM, and Industry 4.0, as well as building the bridge between the industry and education. Dobot Magician is a multifunctional desktop robotic arm for practical training education. With different tools, Dobot Magician can realize interesting functions such as 3D printing, laser engraving, writing and drawing, and so on. And it also has the teaching and playback function. For the programming method, Magician supports scripts as well as graphical programming, which can meet the different needs of users. Moreover, users can easily develop their projects through a wealth of resources provided by Dobot, such as communication protocol, API description, demos, and so on, which makes users' creativity and imagination increase without any limitation. As you can see here, with good performance both in hardware design and software application, Dobot Magician has won lots of awards in the past. Here are pictures showing the main functions of the Dobot Magician: 3D printing, laser engraving, writing and drawing, graphical programming, and script programming, secondary developing. About the secondary developing application, Dobot Magician is compatible to develop users' applications with its 13 I/O ports, API, and released protocols. And it can be developed with several programming languages or with ROS, PLC, microcontroller, and Android. What's more, Dobot Magician is compatible with multiple accessories such as printing material, vision kits, mini conveyor belts, and etc. to apply different training projects. With powerful functions and adaptability, the Dobot Magician can be applied to a wide range of fields and scenarios, as shown in this slide. And after the overview of the Dobot Magician, let's go to the part two, the quick start with the Dobot Magician. Here shows the items inside the Dobot Magician product box. The basic version includes the Dobot Magician, vacuum pump kit, gripper, writing and drawing kit, and 3D printing kit. And for the educational version, the green marked items are additionally included. The technical parameters of the Dobot Magician is shown in this table. As you can see, the maximum payload of Dobot Magician is 500 grit. The maximum reach is 320 millimeters. The repeated positioning accuracy is 0.2 millimeter. And there are three can-solve communication methods of the Dobot magician, namely USB, Wi-Fi, and Bluetooth. There are two can-solve coordinate systems used by the Dobot magician. The Cartesian coordinate system and the joint coordinate system. In the joint coordinate system, the coordinates are determined by the motion joints, and there are two situations. If the end effector is not installed, Dobot magician contains three rotation joints, J1, J2, and J3. The positive direction of the joints is counterclockwise. And for another situation, if the end effector with servo is installed, Dobot magician then contains four rotation joints, J1, J2, J3, and J4. And the positive direction of the joints is also counterclockwise. In the Cartesian coordinate system, the coordinates are determined by the base. The definitions of each axis are described in this slide here. The interfaces of Dobot magician are located on the back of the robot's base and forearm, respectively. This slide shows detailed information about the interface on the back of the robot's base. With the reset key, you can reset the MCU program. And during resetting, the LED indicator on the base turns yellow. In about 5 seconds, if the indicator turns green, that means the reset is successful. Short press the functional key to start running the offline program, and long press the functional key to start the home procedure. And with the communication interface, you can connect the robot via Wi-Fi or Bluetooth, and the Dobot protocol is adopted. The USB interface is used to connect the robot to the computer via Ethernet. And the power interface is used to connect the robot with the power adapter. And you can use the peripheral interface to connect the peripheral equipment, such as air pump, extruder, and so on the robot. Detailed information about the peripheral interface are shown in the table 4.2. SW1 can be used as the power interface of air pump or the output 12 voltages of controllable power. SW2 can be used as the output 12 voltages of controllable power. Stepper 1 can be used as the user-defined stepper interface. Can be used as the user-defined stepper or the extruder interface in 3D printing mode. Stepper 2 can be used as the user-defined stepper interface. GP1 can be used as the single interface of air pump or color sensor interface, infrared sensor interface, or user-defined general interface. GP2 can be used as the user-defined general interface. About the peripheral interface on the magician forearm, GP3 can be used as the end effector or R-axle server interface or the user-defined general interface. GP4 can be used as the interface of auto-leveling or the user-defined general interface. GP5 can be used as the single interface of laser engraving or the user-defined general interface. SW3 can be used as the hot end interface in 3D printing mode, or the output 12 voltages of the controllable power. SW4 can be used as the fan end interface in 3D printing mode, power interface of laser engraving, or the output 12 voltages of controllable power. The analog interface can be used as the thermometer interface in 3D printing mode. The table 4.4 shows the description of the LED indicator on the robot base. Steady green means the robot works normally. Steady yellow means the robot is in starting status. Steady blue means the robot is in the offline mode. Blinking blue means the robot is running homing procedure or auto labeling. And there are 3 possibilities when the indicator goes steady red. Situation 1, the robot is at the limited position. Situation 2, the alarm is not cleared. And situation 3, the collection of 3D printing kits is abnormal. The suction cup kit is the default end effector that comes with the Dobot Magician. And an air pump is necessary when using the suction cup kit. You can install the suction cup kit and connect the air pump to the Magician robot according to the picture shown here. This slide shows how to connect cables to the Magician robot. Step 1, connect the Dobot Magician to the computer with the supplied USB cable. Step 2, connect the electrical outlets to the Dobot Magician with the supplied power adapter. And here shows the correct way to turn the Magician on. Step 1, handhold the forearm of the robot to make the angle between the forearm and the rear arm about 45 degrees. Step 2, turn on the power, and then all the arms will be locked automatically. The LED indicator will change to green. If the light goes into the red, that means the robot is in a limited position. And now, Frankie will show you how to set up the Dobot Magician correctly. Okay, you can see now the LED indicator changed to steady green. It means that the Dobot magician is started all correctly. Okay. So we have just finished the introduction of the quick start with the Dobot magician. Now comes our first Q&A part. And if you have any questions of these two parts, please feel free to unmute and raise your questions. Okay, as I can see, all of you are very professional with the Dobot magician, and no one raised question here. And so I think we can, as you are all clear about the first two parts, we will continue the next part with the part 3, the Dobot Studio software. And currently, the Dobot Studio is the main software with which users controls the Dobot magician. And I think you all are familiar with it. So for this part, I will quickly go through it. You can download the latest version of the Dobot Studio from our official website. And after downloading and installing the Dobot Studio, connecting the Dobot magician to the computer with the USB cable. If the software is installed correctly, you will be able to search the COM port in the Dobot Studio. Also, you will be able to find the corresponding COM port of USB series CH340 in the device management. Here is the introduction video about the Dobot Studio software installation. Due to the time limits, I will not play this and the following introduction videos, but as we have sent the PPT to you, you can check these videos in the future if you want. And now I want to briefly introduce the important function models of the Dobot Studio. Firstly, the teaching and the playback model. Users can teach the Dobot magician how to move, and they then record the movement to make Dobot magician accomplish the recorded movements. And with the write and draw model, you can control the robotic arm to write, draw, or engrave an object by using a laser. Here is the introduction about how to use the write and draw function model. I will skip it. And with the laser engraving model, users can engrave a bitmap image on an object using a laser. An example is shown here. And here is the introduction video about the laser engrave model. I will skip it too. And with the 3D printer model, the magician is capable of 3D printing. One thing to notice is that in Mac system, Dobot can only be available for Cura. Users can use Broccoli to program the robotic arm in a graphic programming environment. It allows the users to drag and drop the blocks into the workplace to generate execute code just as easy as a block parser. And we also provide the integrated API inside the software. About the calibration, there are two kinds of calibration for the magician, namely base calibration and sensor calibration. For the offset of the robot's home position, you can use base calibration. And for the offset of the sensor calibration should be used. And auto leveling is included in the newly published package of the Dobot Magician, which is much easier than calibration board. One thing please to notice is that the Dobot Magician is carefully calibrated before being shipped out. So you don't need to recalibrate your robot before using it. And now, let me introduce our upcoming Dobot software, Dobotlab software, which is used to replace Dobot Studio software. That is to say, in the future, we will focus on developing Dobotlab and stop updating and maintaining Dobot Studio. Dobotlab is an integrated software platform specially designed for AI education. You can enter the Dobotlab online platform through the browser. I will show you an example. There are two ways to enter the Dobotlab platform. One way is to go to our official website, enter the educational part, find Dobotlab education platform, click to enter, or you can directly input this link to enter the Dobotlab platform. And here is the main page of the Dobotlab program, which can be divided into 12 parts. Click here to return to the Dobotlab main page. And this part includes 4 options: currency, help, feedback, and about. Click currency to review the guidance for the main page. Click help to view documents related to the Dobotlab, which I think will be very useful for the new user. And click feedback to enter your feedback about using Dobotlab. Click about to view the basic information about the Dobotlab. And here you can change the language. And users can log in or sign up here. About my course model, it provides free online courses, but you need to log in before you view these courses. And in personal works model, the user can view and edit the saved program project. In future model, there are 6 core experimental models: Dobotlab, Python lab, writing and draw, laser engraving lab, teaching and playback lab, and 3D printing lab. The Dobotlab education platform can support Dobot Magician, Dobot Magician Lite, Magic Box, Air Starter, Magician Go, and Android Smart Kit. There are several notable features of the Dobotlab platform. The advantages of unified educational software and integrated functional models, various of future models. More and more functions will be developed in the future, and variety of options to use the software. We provide online platform and local version. And Dobotlink is the drive software of the Dobotlab hardware devices, which the user needs to install and run before using the hardware devices. The software will remind you with the message if the Dobotlink is not installed or started when you start the Dobotlab. And this slide shows the interface of Dobotlink. As you can see, users can also enter the Dobotlab website, download the Dobotlab local version, upgrade the firmware for Dobot educational products, and calibrate the Magician robots through Dobotlink. This is the firmware update page of the Dobotlink. After connecting the robots, you can view the firmware information of the connected Magician robots. And if you want to update the firmware, click Select Firmware to choose the corresponding firmware, then click Start Update to finish the updating. Users can take base calibration, manual leveling, or automatic leveling in the machine calibration model of the Dobotlink to improve the positioning accuracy. And in this part, we are going to learn the basic operations when using the Dobotlab. Firstly, about the register and login. To use the 4 functions of Dobotlab, it is recommended that users log in whenever use the Dobotlab. And on the login page, you can log in the Dobotlab with a registered account or register a new account when using the Dobotlab for the first time. Click register to enter the register page here and input the required information and click the register to finish the register. After successful register, go back to the login page and enter your account and password to log in. Okay, and I think our friend from SL wants me to pause for a while give you time to install the program. And I think it's okay. And we can also take a short break about 10 minutes. Is that okay? Since Dobotlab platform is all new for you guys, and it is very important for the Dobot magician, I think it's okay. Okay, so let's take a short break for 10 minutes, and then we continue the next part. Thanks, guys. Hello, Yanis. Can you hear me? You need to first register account. You need to first register, create an account, then log in.
Okay. Okay, I tried.
Mm-hmm.
But
okay. You mean this ID?
Yes.
You can input whatever you want.
Okay.
Just follow this requirement.
Okay.
And we have 5 minutes left for the break and for you to create a new account for the Dobotlab platform.
Got crash.
I think.
Okay. Well, hello. One
Hello?
question. Yes, hello.
I can hear you.
Okay.
Please ask.
My colleague has a funny problem. When she want to register, she get the note that she already exists on this account. But later, when she want to log in with the same account, it noted that.
Oh, you mean that when your colleague want to register or create a new account, the software says it already existed.
Yes.
And when you try to log in with this registered account, it failed.
Yes, I get user does not exist.
Okay.
I don't know what to do.
Please wait a minute. I will ask my teammate. Hello, can you hear me? Please send your account number to Frankie, and he will solve this issue. Is that okay?
Username. Is it email? Is email enough?
Enter this counter. What or email is okay.
To Frankie.
To Frankie here. Dobot Frankie.
Okay.
Thanks.
Yes, vamos dar do estado. Santa Nossa,
A ty pisze. Aha,
Okay. Firstly, my friend from SCSL, for your account problem, my Frankie has reported it to our R&D teammate, and he will solve this later. Is that okay?
It's solved now. Thank you.
Okay, it's solved. Okay. Then, okay. So now let's continue the next part. So, okay. So you can click the personal data on the personal center page to view and edit the basic account information such as profile photo, nickname, and so on. And click AI authority on the personal center page to view the usage of the UI data. As you can see here, the time limit of the data usage is 99 per month, and it will be renewed in the next month. And in the account setting, you can delete your account. In all courses model, you can check all courses provided to you. And currently, we provide 4 courses for all the users, and the number of courses will be adding in the future. So there will be more and more courses free to our users. And for my works, you can enter the name to search my work here, and it all saved your saved project. Okay, and now I will introduce the 3 kinds of programming function models of the Dobotlab education platform. Firstly, the teaching and playback lab. Teaching and playback lab supports multiple Dobot hardware devices, including Magician, Magician Lite, and Magician Lite plus Magic Boards. Here, I will take Magician, for example. Section 1 is the program control function. Click Start to start running the commands. Click Download to download the point list to the robot arm. And Section 2 is the operation settings functional model. Click Settings to set speed and acceleration. Click Command Panel to set motion mode, pause time, and effector. And Section 3 is the log function. Click Log to display the alarm information. And Section 4 is the menu function. It includes currency, help, feedback, and about, which I have just described. Section 5 is the home function. You can click here to back to Dobotlab main page. Section 6 is the file function. It includes functions such as new, open, save, import, export the file, and etc. And in section 7, you can fill the name of the current project or edit it. Section 8 is the device connection function. Select the target device and establish a communication connection with the device. And section 9 is the robotic arm control panel. You can click here to control Dobot Magician or Magician Knight. Section 10 is the comment area. To display the edit comment, and you can right-click a comment to copy, paste, or delete it. And later, Frankie will show how to make it move in the real situation. And here is the detailed description of all the function in the teaching and playback model.
Hello.
No?
Sorry, we are staying behind. We don't find this in the Dobotlab. Can we talk separately with Frankie that we will?
Hello?
Hello?
Can you type your question in the chat area?
Okay.
Thank you.
Okay.
Okay, and I will begin, and my teammates will answer your question in the chat area. Is that okay? Okay, let's begin. And about the motion function, you can control the magician to move under the jogging mode. Jogging mode is the mode jogging Dobot magician along the Cartesian coordinate system or joint coordinate system when teach. And the detailed description is showing here. And there are two motion modes for the Dobot magician. One is the P2P mode, which is the point-to-point movement, and it includes the move J, move L, and the jump command. Move J is the joint movement from point A to point B. Each joint will run from initial angle to its target angle, regardless of the trajectory, as this, for example. And movement L is the rectilinear movement. The joint will perform a straight line trajectory from point A to point B, as shown here. And another movement mode is the jump mode. From point to point B, the joints will move in move J mode, of which the trajectory looks like a door, shown here. So firstly, it will move up the lifting height from point A, and then move horizontally to a point that is above B by height here. And lastly, it will moves down to point B. The third motion mode is the arc mode. The trajectory of arc mode is an arc, which is determined by 3 points: the current point, the middle point, and the end point on the arc, shown here. And to notice that in arc mode, it is necessary to conform the 3 points with other motion modes like move J or move L, and the 3 points cannot be in a line. The application scenario depends on the trajectory in motion mode, and detailed description is shown in table 3.1. And now Frankie will show how to control the magician to move in these 3 motion modes that I just introduced with the teaching and the playback function. And I will stop my share. Firstly, enter the teaching and playback lab model. As you can see, the Dobot link is not started. You need to start it. I just introduced this situation before. Now the Dobot link is started successfully, and you can use the Dobotlab platform now. First step, connect the magician robot to the computer, and then enable the robot arm. Before you take the movement control, please do the home calibration. Okay, home calibration finished. You can see now the robot is moving in move J mode. And now I cannot see the robot. You can see the robot through the window of Dobot Frankie. Hello, Sekita. Can you see it now? Just a share screen. You need to go to the participate fund Dobot Frankie and double click to view Dobot Frankie's screen. Spotlight. Okay, we'll do. I just spotlight Frankie's window. Okay, since one friend didn't see the Dobot magician robot screen, Frankie, please redo the movements again. First, okay, let's begin. So first, so Frankie is now showing how to control the Dobot magician to move in 3 motion mode. First one is move J. You can see the robot move from point 1 to point B in joint movements, regardless of the trajectory. And now Frankie is showing the move L. See, right now the robot is moving along a straight line trajectory. The last one, jump movement mode. See? Okay. And you can, for the jump movement mode, you can set several parameters. First is the height of the door type. Okay. And the lifting limit height of mechanical arm limit. Okay. And here you can set the loop number of the movement. Now the robot will do the jump movement 3 times. As Freaking just set the loop number as 3. And there you can also set several parameters here. For example, the pause time and the end effector setting, the loose step check, the IO trigger settings. And about the detailed information, you can also find the Dobotlab program menu or device menu here. Okay, we just finished the introduction of the movement mode. And now we will go to the second program function model of the Dobotlab, which is the Dobotlab. Dobotlab is the graphical programming function model with which users can complete AI programming tasks by dragging blocks. The main interface of Dobotlab is shown in this here. And the menu function contains the currency here feedback above, and the home function back to the main page. Fail function includes a new open save upload from local, the related file edition function, and the project name. You can view and edit the current project name. And the block area provides programming blocks. You can find the required blocks according to the classification of the color here. And here, section 6 is the code area. You can write a program by dragging the blocks directly to this area. And here is the display area. It can display rows and corresponding programming works. Click this one to run the program. Click the red icon to stop running the program. Click this icon to clear the alarm. Click this one to switch the layout, and click this icon to enter full screen mode. And section 8 is the control area. In here, you can select device, control the connection, jogging control, speed control, and the split and backdrop selection and drawing. This slide shows the detailed description of the main page of the Dobotlab. And briefly introduction about the Broccoli. Broccoli is a graphical programming method rather than text-based. Lines of complex code are represented by simple blocks that fit together to form a program. We will take the jump instruction as an example to introduce the block instructions in Dobotlab later. And if you want to learn more about the Broccoli introduction, you can check the Dobotlab programming manual in Dobotlab, which can be found according to the marked picture here in the menu icon. And here shows the Broccoli program demo of the jump instruction. It is used by using suction cup kit. Magician robots moves the 4 horizontally arranged color blocks to other positions through this demo. And frankly, we'll now show how to accomplish this demo step by steps. Firstly, connect the Magician robot in the control area and do the home calibration. B, it means the robot just finished the home calibration. Creates a new variable as the coordinate offset, and then the start command. Set the coordinate offset value to 25, which is the height or the length of the cubus here. The first point in the purple in the first movement command is the initial point. Okay, I will introduce. So firstly sets the value of the coordinate offset to 25, which is the height or length of the cuba. And this is the end effector, which is the suction cup set comment. And this go to this point 1, which is the initial point, and then go to the point 2, which is the peaking point of the first cuba. You see, this is the coordinate offset, and then turn the suction cup on to suck the cuba, and go to the drop off point, turn the suction cup off, and plus the length of the cuba to suck the second cuba. We need to do it 4 times because there are 4 cups to pick up. Okay. Okay. Is everyone clear with this demo? If so, please type 6 in the chat room and I will continue the next part. Okay, thanks. You are all very friendly and warm. Okay, I will share my screen now. And now I will introduce the third programming function model, which is the Python lab. Here you can see this is the main page of the Python lab model, function model. Section 1 is the log function, which displays the alarm information. And the section 2 is the program control function. These two, run and download, is same as run the script, and the download to download the current program in the code area to Magic Box. And package management is to install the Python extension library, after which you can call the library function in the extension library. And section 7 is the device connection. Section 8 is the car control panel, with which you can control the Magician Go. And section 9 is the robot arm control panel to enable or disable the robot arm. And section 10 is the command list area, which provides programming comments, and you can double click comments to display code in the command area, code area here. And section 12 is the running log function, which displays the running process. And here shows the detailed description of all functions in the Python lab main page. And here shows 2 examples of the Python API. First one is the set and suction cup. This API is used to set the status of end suction cup. And the required parameter is enable to enable status of suction cup. True means to enable the suction cup, and false means to disable the suction cup. The parameter on is to control or release of gripper. True means to the suction cup grips, and false means the suction cup releases. And the return value of this API is true or false. True means the command has been finished, and false means the command has not been finished. An example of this API is here. With this command, the suction cup is enabled to grip. And the second example of API I want to introduce is the P2P movement. And the required parameter is showing here, which you can check later. And to learn more about the Python programming in the Dobot Python lab, you can check the Dobotlab programming manual in Dobotlab manual convention area, showing here. And also, here shows the Python demo of controlling the end suction cup of Dobot Magician to move the block from point A to point B. You can view this code, and Frankie will also show us how to accomplish this demo by using the Python API. Firstly, enter the Python lab function model. Connect the magician robot as always. And you can easily double click the API in the left area to put it into the code area. With this API, magician point set home to do the home calibration. And first one, the PT point-to-point movement API. The first one is the starting point. And the Frankie is now controlling the robot to find the first point to the point A. Now the robot arm is at the first Kuba and set the end effector suction cup enable and turn the suction cup on. And now setting the point where to drop the Kuba. You can easily control the robot arm to move in the control pillar, right? And after you find the correct position, you can just copy the coordinates to the corresponding command. So firstly, set the coordinate values of the picking point. Turn the suction cup off to drop the cope and move to the initial point. You can say, frankly, just input, I think, input a wrong value of the coordinates, and he will recorrect it. And freaking is not doing an additional task to place the cuba to the initial point, the past position. Okay, perfect. Okay, the introduction of the Python lab is finished. And if you have question, you can type it in the chat area. And now I will begin our last part of today's training, the FAQ. Wait a minute, I will show my screen. And firstly, I will show you guys some normal frequently occurred question by us. And after that, if you have question for today's training, and you can unmute and raise it up. The first question is here. Dobotlab is the drive software for the Dobotlab hardware devices. And before using the hardware devices, you need to install and run Dobotlab, which I have already introduced. And the users may fall to install Dobotlab software and always prompting the following 3 errors. And the answer is, you don't need to care about this profit. The installation failed because it has been installed before. And just click Fine and OK to run the Dobotlab. The question 2, how to distinguish the version between Magician V1 and V2? There are several ways. Firstly, the color of the ports of their ports are different between Magician V1 and Magician V2. V1 has white ports and V2 has colored ports. And the V2 is an upgraded version of V1. It mainly upgrades the mainboard and comprehensively improves the performance of the Magician. Here shows the detailed differences between V2 and V1, which you can check it later. And question 3, after Magician is turned on, the indicator that doesn't light up. And after clicking connect in Dobot Studio, the current serial port is not connected to Dobot. Please select the correct port pops up. And the robotic arm can no longer be connected normally. And for this case, the Magician needs to be reborn the software with the firmware. And please use the Microsoft tool in Dobot Studio passes this to manually build the firmware to solve it. And if the indicator light shows up normally, please also follow this method to deal with it. And if you still have problems or issues with that, please contact us and we will help you to solve this problem. And question 5, Magician cannot turn to home position properly. And the answer is here. You can follow the description to do it properly. And there are some information if you need more support corresponding, if you have corresponding or related question or need more information, you can just to check this link. Okay, so that's all about today's presentation of this training. And if you have any questions, please be free to unmute and raise up, and we will answer them. Can the Dobot magician make me a sandwich? Oh, okay. Funny. So, any other questions? And I also need you feedback about today's training. If you think today's training is perfect or good, everything works fine, well, by your side, please type 6 in the chat area. And for any suggestion or advice to improve our training, and you can also type 8, and we will mark it to improve our improvement. I can help to connect the okay. Hello, my friend from ICSL. About the connection with the conveyor bits, I think we will do the special training in the next time. And if you need to solve it immediately, please contact Frankie later, and we will help you with it today. Okay.
Okay.
Okay, and about the question from Ayadi, for laser cut, how much the maximum depth? I will about this parameter, we will confirm it with our R&D team. And sorry, I cannot answer you right now, but later I can provide a correct value. Okay, I think they are sorry. I mean from USB flash. Okay, I think right now everyone here, my friends, is all clear. Are all clear about this, about the content from today's training, right? And if you have further information such as application of the Dobot Magician, you can just send an email and get a response. Okay, I will report it to Ryan and he will answer your question by email today. Is that okay? Porphyrias? Thank you. Thank you for your understanding and support. And thank you. And okay, I will left the last 5 minutes. If you have for you to raise the question about the content of today's training. And if you have other questions, you can send email to our support team's email, and I believe my teammates will answer you on time. Okay. Okay. Ryan, please type the support email. Ryan is responsible for the tech support from our customer in European area, and he just shared his email. And in the future, if you have any questions about our educational products, please feel free to contact with Ryan, and he will give you the professional tech support service. Okay, and I think everyone, my friends are all clear 100% about today's training. And I and my teammates, very thanks for your time with us, and we will finish it in 1 minute. Okay, it's time to say goodbye. Thanks again for your time, my friends, and wish you a good day and good work. Bye-bye.